So acceleration of an object can be zero. These are the possibilities. It can be a constant or uniform. It can be increasing. It can be decreasing, or it can be deceleration. So acceleration of an object may have a zero acceleration. The object may have a uniform or constant, uniform or constant, same thing, acceleration. It may have increasing acceleration. It may have decreasing acceleration. And it may be decelerate. These are the terms which can be used for acceleration, like zero acceleration, uniform acceleration, uniform or constant acceleration, increasing acceleration, decreasing acceleration, and decelerate. So first we discuss the meaning of zero acceleration. The term zero acceleration means when velocity of an object does not change, the object has zero acceleration. And what are the possibilities for zero acceleration? In case of zero acceleration, like zero, this is the first case, so number one. And zero acceleration, what are possibilities? Maybe the object is at rest. When object is at rest, we can also say its acceleration is zero. Like example, say you have a book, a physics book, which is you left it on the table. So what is the velocity of this physics book which is at rest? What is the velocity of this physics book which is at rest or not moving? So as this book is at rest or not moving, its velocity is zero. And after 10 seconds, this book will remain at its position. So after 10 seconds, when you monitor, the book by itself does not move, so it will remain at its position. So what about the acceleration of this book? There is no change in the velocity. So acceleration of this book is 0 meter per second square. So whenever the object is at rest, the object is not moving, it will not have any acceleration, or it will not have any change in the velocity. So we can say this object is having a zero acceleration. This is one part. Or the second possibility for zero acceleration, when object move with a constant speed without changing the direction. So object is moving in with a constant speed or same speed without changing the direction. In that case, we also say this object is having a zero acceleration. Example, say a car is moving from one place to another with the same speed of 3 meters per second. and the time it was taking 2 seconds to travel from position A to position B, and it was taking 2 seconds to move from position 2 to position B to C. So what is the acceleration from A to B? Moving from A to B, acceleration is a change in the velocity. So this is the final velocity, which is 3, minus initial velocity is also 3, divided by time interval 0. So acceleration from A to B, 3 minus 3, that is 0, divided by 2. So acceleration is 0 meter per second square. Same way, moving from B to C, so this is the starting speed of B and 3 is the final speed. So acceleration is final speed minus initial divided by time. So 3 minus 3 is 0. So 0 divided by 2, that is also 0 meter per second square. So when object is moving with a constant speed without changing the direction, the acceleration of the object is 0. So we have two possibilities of 0 acceleration. Either it will be at rest, we can say it is having a 0 acceleration, or the object is moving with a constant speed, does not change its speed, we also say it is having a 0 acceleration. Is it clear? The first part, the concept of 0 acceleration. The second case, the second condition, a uniform or a constant acceleration. Like we are discussing all the cases for, because acceleration can be a 0 acceleration, it can be a uniform acceleration, it can be increasing, it can be decreasing, or it can be a deceleration. So we discussed the first one, we completed. Now we will discuss uniform or constant acceleration. The meaning of uniform or constant acceleration. The term uniform or constant acceleration means that every second speed or velocity changes with same rate. So every time the speed or the velocity changes with the same rate, that we call as a uniform acceleration or constant acceleration. So we have an object at different position, like starting from position A, then move to position B, then to position C. Example, the object was moving with 5 meter per second at position A. Then it was moving with 7 meter per second at position B. Then it was moving with 9 meter per second at position C. And the time it will take to travel from A to B, that is 2 seconds, and from B to C, that is also 2 seconds. So what is the acceleration from A to B? So what is the acceleration from A to B? From moving from A to B, that is the final, that is 7. Initial, that is 5, divided by time, that is equals to 2. So 7 minus 5 divided by 2, that's equal to 2 divided by 2, and 2 divided by 2, that's equal to 1 meter per second square. So acceleration from A to B, tell me, Abdullah Sarfraz, what's your question? The meaning of acceleration is called the change in the velocity. The term acceleration refers to the change in the velocity. So when there's a change in a velocity in a specific time, we call that as acceleration. So an object at position A was moving with 5 meter per second, and at position B it is moving with 7 meter per second. So what is the change in the velocity? It is 7 minus 5 divided by 2 equal to 1 meter per second square. But what is the acceleration from B to C? The change in the velocity from B to C? So moving from B to C, position B, the final speed is 9 and initial speed is 7 divided by time interval is 2. So 9 minus 7 is 2 divided by 2. That's equal to 1 meter per second square. So in this example, the acceleration of an object is not changing. In the beginning it was 1 meter per second square, like from A to B it was 1 meter per second square, from B to C it is also 1 meter per second square. So when the value of the acceleration is not changing, what we call, or what we use the term, that this object is having a uniform acceleration, uniform change in the speed. Is it clear? The term uniform acceleration. Yeah, 2 meter is changing with respect to time, because acceleration is the change in the velocity divided by time interval. So here the change was 2 divided by time is also 2. So 2 divided by 2, so acceleration is coming out 1. And here the change in the velocity is 2 divided by, because acceleration is change in velocity divided by time interval. So change in the velocity is 2 and the time interval is also 2. So 2 divided by 2, again you will get 1 meter per second square. So it means this object is having a constant speed is changing, but acceleration is constant or uniform acceleration. Then the third case, increasing acceleration. What is the meaning of increasing acceleration? So the term increasing acceleration means the value of the acceleration will increase. We call that as increasing acceleration. So an object is there moving with different speeds, because for an object to accelerate, the speed should change. At position A, it was moving with 5 meter per second. At position B, it is moving with 7 meter per second. And at position C, it is moving with uh, 10 meter per second. And the time interval, because acceleration is change in velocity divided by time, so time interval is 2 seconds here, and that is also 2 seconds. So what is the acceleration from A to B? the value of acceleration from A to B, moving from position A to position B. So it will be 7 minus 5 divided by 2. So 7 minus 5 divided by 2, that's equal to 1 meter per second square. When you calculate the acceleration from B to C, so the acceleration from B to C, C, the final is 10, initial at B is 7, divide by time is 2, so 10 minus 7 divided by 2, 3 divided by 2, equal to 1.5 meter per second square. So what is happening to the value of the acceleration? First it was 1 meter per second square and now it is 1.5 meter per second square. So the value of the acceleration is increasing. And when the value of the acceleration is increasing, we call that it is increasing acceleration. Is it clear, this example? The term increasing acceleration. And decreasing acceleration, the meaning of decreasing acceleration. The term decreasing acceleration means the value of the acceleration will decrease. Here it was moving, example, with 5 meter per second at position A. At position B, it is moving with 7 meter per second, like it will cover 7 meters in 1 second. And C, it is moving with 8 meter per second. The time interval for moving from A to B is 2 seconds and moving from B to C is also 2 seconds. Now, what about acceleration from A to B? So acceleration from A to B, the final is equals to 7, initial is 5 divided by 2, that's equal to 1 meter per second square. But when we calculate acceleration from B to C, so acceleration from B to C, at B it is 8, C it is 7, and time interval is 2, so 1 divided by 2, that's equal to 0.5 meter per second square. So you can clearly see that the value of the acceleration is decreasing. Is it clear, this example? Even though the speed is increasing, but the acceleration is decreasing. Like here, from A to B, there is a greater change in velocity with respect to time as compared to from B to C, there is a small change in velocity with respect to time. When you calculate the acceleration, acceleration is change in the velocity divided by time. So what is the change in the velocity from A to B? So the A to B, the change in velocity is 7 minus 5. And what is the time interval? The time interval is 2. So 7 minus 5 divided by 2. So the change in velocity divided by time, you will get acceleration as 1 meter per second square. But from B to C, The speed is increasing, but the change in speed is smaller. Here, speed was 7, then it changes to 8. So what is the change in the speed? The change in speed is 8 minus 7, which is equals to 1, divided by the time interval, 2 seconds. So 8 minus 7, that is 1, divided by 2. So you will get 0.5 meter per second square. So the change in the velocity with respect to time from A to B is greater as compared to from B to C. And acceleration is refers to change in the velocity with respect to time. Is it clear, Abdullah Sarfraz? So acceleration mainly refers to change in velocity with time. It does not depend on the value of the velocity. Value of the velocity might be increasing, might be decreasing, but the change in the velocity that matters. If the change in the velocity is greater, acceleration will be higher. If the change in the velocity is smaller, acceleration will be smaller. As you can see from A to B, it was the change in the velocity was 2. But from B to C, the change in the velocity is only 1. Yes, Abdullah Sarfraz?
So, sir, velocity is not being changed from B to C.
It is changed from B to C. From B it is 7 and C it is 8. But the change is smaller. Moving from changing velocity from 7 to 8, what is the change? It's only 1. But from A to B, it is initially this velocity was 5 and then it is 7. So what is the change in the velocity? That's 2. So greater change from A to B, that means greater acceleration from A to B. Smaller change from B to C, that's why smaller acceleration from B to C. It is accelerating, but it is having a smaller acceleration or smaller change. Is it clear?
Yes, sir. So, acceleration will decrease when it is like 5, then 4, and then 3. Will still decrease?
Yeah, it will, but that is called deceleration. I got your point. You're thinking about change in the velocity in terms of decrease in velocity. What you're saying is related to the next part, which we call deceleration. The term deceleration means that the speed or velocity will decrease. So example, and this deceleration can be of two types. When the speed or the velocity decreases, we call deceleration, and it can be a constant deceleration. It can be a variable or changing deceleration. So an object is changing the speed. Here the speed is 5, then 4, and then 3. So whenever the speed of the object is decreasing, like the value of the speed is decreasing, we use the term deceleration. And deceleration can be constant, it can be variable. Like example here, the time interval is 2 seconds, time interval is also 2 seconds. What about the deceleration of the object? It's final minus initial. So final is 4, initial is 5, and divided by time, that's 2. So 4 minus 5, that is minus 1 divided by 2, and minus 1 divided by 2, that's equal to 0.5 meter per second square, negative. When I calculate a deceleration from B to C, that is final is 3 and initial is 4 divided by time interval, that is 2. So this will come out minus 1 by 2 or equal to minus 0.5 meter per second square. So when the value of the speed is decreasing, we call that as a deceleration. And you can see it is decelerating because decelerating is a term used for decreasing speed. But the value of the deceleration is same. So we call that is a constant deceleration. Is it clear? The concept of the term deceleration means that speed should decrease. Whenever the speed decrease, we call deceleration. If the speed is decreasing with the same rate every time, same value for speed changes, we call it's a constant deceleration. But the variable deceleration means that speed is not changing with the same rate. Sometime it's changing like in the beginning maybe it is changing faster. So here example, it is 5 meter per second, then it is 3 meter per second, then it is 2 meter per second. So what about the deceleration? Whenever speed decrease, we use the term deceleration. So what is the deceleration? 3 minus 5 divided by, example, the time interval is 2 seconds. So 3 minus 5 divided by 2, that's equal to minus 2. So minus 2 divided by 2, that's equal to minus 1 meter per second square. And when you calculate deceleration, it is all calculated with the same formula of acceleration. The only difference is that deceleration means the value of the speed is decreasing as well. So 2 minus 3 divided by 2, that's equal to minus 1 by 2, which is equals to minus 0.5 meter per second square. So this is called a variable deceleration or not a constant deceleration. Deceleration is changing. Is it clear, the concept of deceleration? What if you're saying the speed was 5, 3 and then 7? So it means the object is as you ask a question, Abdullah Sarfraz, like 5, 3 and 7. Yeah, constant deceleration means it's not changing, the value is not changing for acceleration. So Abdullah Sarfraz, you mentioned it moved from 5, then 3 and then 7. So what is the how we explain this? So moving from A to B, it is decelerating, and moving from B to C, it is accelerating. So these are the 5 cases which you have to learn about acceleration. That object might have zero acceleration, uniform or constant acceleration, increasing acceleration, decreasing acceleration, or decelerate. And deceleration have two parts. It might be a constant deceleration, it might be a variable deceleration. Is it clear, the concept first about acceleration, which is a change in the velocity in unit time? So change in velocity divided by time we call acceleration. And acceleration can be a zero acceleration. It means the object does not changes the velocity. It may have a uniform acceleration. Uniform acceleration means velocity will change but with the same rate. It might have increasing acceleration, the value of acceleration might increase. It might have decreasing acceleration, or it might have deceleration. The term deceleration means that the value of the object speed or the velocity will decrease. Is it clear, this whole concept? So we'll move on to the questions. use screen annotation to answer this. If they ask what is average acceleration, maximum acceleration, yes, Saim Ahmed, you have a question? So if they ask initial acceleration, final acceleration, average acceleration, maximum acceleration, that's the same thing. So we want to calculate an acceleration, and the formula for acceleration is the change in the velocity or final velocity or speed, because if direction is not given, you can consider both as same, minus initial speed or velocity divided by time interval or time. In short, you can write time or time interval, that's the same thing. So we want acceleration from 2 seconds to 3 seconds. So what is the acceleration of this sprinter between 2 seconds to 3 seconds? So at 2 seconds, what is the speed of this runner? So at 2 seconds, what is the speed? 4.1. So 4.1 is the initial speed, or I can say u. At 3 seconds, what is the speed? 5.7. That is v. And what about the time interval? Yeah, there are two time, but we take a time interval, like time between. So from 2 second to 3 second, what is the time interval? We take a difference in the time because we take a time interval. So final velocity is 5.7. Time interval, time not mean, interval means the difference. Like if you say, if you move at one point, at 2 seconds you was at point A, and at 3 seconds you are at point B. So what is the time interval to move from A to B? At 2 seconds you was at position A, and that you was having a speed of 4.1. At 3 seconds you have a speed of 5.7 meter per second. So the time interval to move from position A to B, it's 1 second. So final velocity is 5.7, initial velocity is 4.1, and divide by time interval or time difference, that is 1. So what is the answer? So 1.6 divided by 1 and 1.6 divided by 1. So it will come out as 1.6 meter per second square. So A should be the right answer. Is it clear? Same thing, if I change the question and remove the options, is it clear to everyone? Because I will change the question. So first you should be sure of this. Example, if I change the question and not giving the option, like making this as a question, and I change the time as well from 1 second to 4 seconds. What is the acceleration from 1 second to 4 seconds? And acceleration is, then you will get the answer in number. Acceleration is final minus initial divided by the time interval. So what is the final speed? 4 seconds speed should be the final one, and 1 second speed should be the initial one, and divide by time interval. So what's the answer? You can type your answer. You can use the screen annotation and just type your answer on so I can see. The acceleration of the object. 1.6. So what you did at 4 second, it is 6.5 minus initial is 1.7 and divide by time interval. What is the time interval here? So time interval is 3 because from 1 second to 4 second the time interval is 3. So 6.5 minus 1.7 divided by 3, that's equal to 1.6 meter per second square is the right answer. And when we check the acceleration of this object, like whether this object is having a constant acceleration or no, like when I check, if I label the position A, B, C, D, and E, yeah, 1.6 is the right answer because 4.8, this is 4.8 divided by 3, so 4.8 divided by 3, you will get 1.6 meter per second square. That will be the right answer. Is it clear, this question? I just changed the question to give an idea. Which statement about acceleration is correct? It is a distance an object travel in 1 second. That's wrong. You can use a screen annotation to state the answer. The force acting on the object divided by distance, no, because acceleration is a change in the velocity. Change in velocity you can write like delta V. Force acting on the object when it is near to Earth, that's not acceleration, that's a gravity. So it is related to change in speed of an object. So A is the right answer. So this is about acceleration. Next session we will do more questions from acceleration. Any question related to the class today? Any doubt or a question? And every Tuesday you will submit your weekly homework before 1 p.m. and it is compulsory for everyone. And every Sunday you will send your class notes related to physics and chemistry, what you prepared. The last MCQ, less than a minute left, so maybe I won't be able to complete it. Look, the term, what is the meaning of acceleration? Acceleration means it is a change in speed or change in velocity. That's why A is the right answer. It is distance traveled in 1 second. So distance traveled divided by time is not acceleration, it is speed. A force acting divided by distance. So it is not force divided by distance, that's also wrong. And it's a force acting on the object when it is on the near to Earth. That's not the acceleration, that is equal to the weight of the object. So the statement A explains the acceleration correctly. Physics homework I will share today.